In this video, we're going to look at using right triangle trigonometry to solve an application problem. And in this particular problem, we're not given a picture. So we are going to have to come up with the picture and then figure out how we want to solve it. A ladder is safe to use when it makes a 75-degree angle with the ground. How far up a wall will a 12-foot ladder reach? And I did Google this to see what is the safe angle to place your ladder with the ground, and 75 degrees was what I came up with. So we're going to need to draw a picture. We're going to need a wall, we're going to need a ground, and even though it doesn't say it in here, let's go ahead and assume that the wall and the ground form a 90-degree angle. Probably should say that in there somewhere, but we'll just assume because it could be on a hill. Alright, so now we're going to need our ladder. Let's draw our ladder. I'll try to draw this sort of freehand here. So there's the ground, there's the wall. Our ladder is going to lean up against the wall here like this. There's our ladder. Alright. And it forms a 75-degree angle with the ground. So can you picture where that 75 degrees is going to be? Hopefully. It's going to be right here, 75 degrees, the ladder with the ground. And what other piece of information do we know? Well, we know it's a 12-foot ladder. So we know this side here is 12 feet. And we know this is our right angle here. And we want to know how far up the wall the ladder will reach. So we want to know this distance from here to here. Alright, so that's the setup. That's the first thing you want to do is draw a picture. Now we want to figure out which one of these formulas is going to be useful to us. The first thing you need to do is figure out what angle you're going to use. We might as well use the 75. I mean, you could find this angle up here if you wanted and use that one, but I don't see really any benefit to that at this point, unless you want to just do it two different ways for fun. Okay, so from the 75-degree angle, we want to know this side over here. What side is that? Adjacent, opposite, or hypotenuse? Hopefully you're saying that this is the opposite side. It's the side opposite the 75-degree angle. And we know the 12. What side does that represent? Well, it's across from the right angle. It's the longest side, so that makes it the hypotenuse. This side on the ground would be the adjacent side, but we don't know that number. We don't want to know that number. We could figure it out, but it's not what the question is asking for. So I'm going to go ahead and just not worry about this for right now, and I'm going to focus on the opposite and the hypotenuse, which is sine. Okay, so I'm going to set up my formula, and it's going to be the sine of the angle, which is 75 degrees, is equal to the side opposite divided by the hypotenuse. So the side opposite is x divided by the hypotenuse, which is 12. Alright, there's my formula. Remember, all these formulas have three variables in them, two sides, and then the angle. And you're going to need to plug in two of those three things in order to figure out the other thing. Now you might be asking, what if I knew the two sides? Could I find the angle? The answer is yes. It's not going to be covered in this video, but it is something that you can do, and it's not that hard. Just a little button on your calculator, and you can figure out the angle if you needed to. Alright, so to solve for x, we need to get x by itself, so we need to get rid of this 12. How are we going to make that go away? Since it's divided by 12, we're going to multiply by 12, so those cancel. And we know if we multiply one side of an equation by 12, well, then we got to multiply the other side by 12. So x is going to equal whatever 12 times the sine of 75 is. So let's get our handy-dandy calculator. And let's find the sine of 75 and then multiply that by 12. And we get 11.5911. Now I'm going to talk about how to convert this to inches and feet. We know this 11 is feet, right? So, I mean, in our world, we probably wouldn't say 11.6 feet. We'd probably say 11 feet, so many inches. So in order to turn this into inches, what you're going to do is subtract off just the 0.59 part into inches. I don't want to turn the whole thing into inches. I want, like, let me show you over here. I want 11 feet so many inches. 11.59. So we got 11.59 feet. So I want to say that's 11 feet and how many inches? I want to figure that out. So to do that, I'm going to subtract off the 11, so I just get the decimal part. Basically, I want to know how many inches is 0.59 of a foot. Well, 0.5 of a foot is 6 inches, so it should be a little more than 6 inches. And the way to figure it out is to multiply by 12, since there are 12 inches in a foot. Looks like 7.09. So if I was rounding to the nearest inch, then I would say 11 feet 7 inches, and I probably should say approximately, since we're rounding. All right, so this is a nice application of right triangle trigonometry and how it's used in very, very useful applications, all kinds of useful applications. The key to this one is to first draw your picture. Oh, now my pen's going to get a mind of its own. All right, well, I hope that was helpful, and good luck.